Hello guys, in this video we are going to talk about the UMASK. The UMASK is the way Linux measures the default settings. What does it mean? It means if I set up my UMask to a special permission now, that means my older files will not be affected, will not be changed. It will only affect the files that I'm going to create tomorrow or the folder that I'm going to create it from now on. So the minute I change my UMask, it will only affect the files and the folders I will create after this, not the one that I created before. The one I created before, if I want to change the permission, I have to change it within the change mode or the ch mode command. But for now, we're talking about how to set up a default permission. Why do I need to change that? Why do I need to play with this? Let's assume you are on a special network where you do all your time with a special permission that it has to be like all the users have this permission, the groups don't, these guys, yes. This is where you change the UMask. So the new files will come up with this permission. So for example, for us in the classroom, we set up the permission to allow the group to read and write from your folders. That way, the teachers and the student can help each other copy files from each other. In other examples, says, no, we don't want that. Each student by himself by default. So we change the UMask. And that way, all the files that get created will have that default settings. So how things get calculated? So you should be already aware of this permission and how they get measured. So let's understand now the first concept. There is a very important concept, which is like this. Usually directories need execute permission. Good? They need execute permission directory. Otherwise, people will not be able to open them. People will not be able to do CD and go to the folder name or the directory name. So the execute permission is very important for the folder. On the other hand, the execute permission is not important for the file. And we don't usually do it. 90% of our files are just files. When you change the file and give the file an execute permission, that means you are making that file as an executable file. That means this file now will be executable, will be a program that you can run on your computer. How often do you do that? So that's why by default, they don't give the files executable permission by default. If you want to change the file to executable, you use the change mode and you can do it from there. So when you look at this, so the maximum that I can give to a directory is what? I can give the directory read, write, executable, read, write, executable, read, write, executable. That's total up to 4 plus 2 plus 1, that's 777. So the folder can get maximum 777. Good. While the files, since I'm not going to give them executable permission by default, that's why a maximum can give them is 4 plus 2, 4 plus 2, 4 plus 2, which means 666. So this is where those two numbers coming from. They're coming from the fact that folder need executable permission by logic, while files don't need it unless in very special cases. Good. So what does that mean? Based on that, if I assume that I have a UMask of 0022, of course the first zero we don't care about. If you want to know your UMask, you will go to your Linux system and you type UMask. You press enter, it will tell you the UMask. Good? So that's my UMask. So what does that 0022 mean? How do I calculate what does it mean for me? I need to understand what does that mean. So it's simple. For the folder or for the directories, we will do 777, which is the maximum that we can give to a folder, minus the UMask. 777 minus 022, that will equal to 755. 755 will translate to what? Based on this schedule. So 7 mean RWX. The 5 mean R and X. So that will translate as follow. Good. 755 will translate to RWX for the user, which is 7, R and X, which is 5 for the group, and R and X, which is 5 for the other. What does that translate to English? It translates that by default, the user will have a full permission on the folder, read, write, and execute. While the groups and the other, they will only have read and execute. Good. They can read the folder, they can execute the folder, they cannot write or create stuff on it. Now for the files, it's the same thing, but you do 666 minus UMask. So 666 minus UMask equal to 644. Good. The UMask here is 002 as I'm saying, 022, sorry, which means the RW minus for the user, R minus minus, and R minus minus based on this schedule. Here is the 4. 6 will mean these two. 4 mean this. 4 mean this. So that means it is RW minus, R minus minus, R minus minus. When you look at it, that means what? That means user will have read and write, while the group will have, and the other will have read only. Good. So for the files, by default, your group and the other people can read only the files, but they cannot write, they cannot do anything about them, and you can read and write. No execute here, because that, again, we don't do execute for the files unless we are converting them from a normal file to a program file. Good. Here is another example. So another example, what is if my mask is 022 Good. Again, 002, follow the same steps. 777 minus the UMASK, make it 775. 775 mean RWX, R minus X. Again, if you don't know where the 5 is coming from, you look at the schedule on the top. To get a 5 from this, it is 4 plus 1. There is no other way to get 5 unless you do 4 plus 1, which means R and X. So this is where the 5 is coming from. Good. So 775. So what does that mean? Here is the permissions. So in English, it means the user and the group, both the user and the group, good, are having a full permission on the folder. So they can have read and write and execute. While others, the other group, have only read and execute. The other group have only read and execute. Good? It's very clear, I think? Hopefully. Let's look at the files. Good. So the files again is 666 minus 002. That means 664. That means RW minus R minus minus. So what does that mean? That means again, the users and the group will have a read write by default on the files, and the other will have read only. This is how you calculate what is it. Now somebody will tell me what you are doing now is easy because you already have the UMASK and you want to figure it out what is it. So now let's look at another example, or what we call it a reverse example. So what does that mean? It means I don't care about my current UMASK. I want my default to be as follow for my files. I want my user to have read write, and my group to have read only, and my other to have read write. This is how I want it. Why? Let's not discuss why. Let's assume this is what you want. You want your user to have a read write, your group have only read, and the others have read write. Good. So how do you do it? What UMASK value should I use? In this case, you will be calculating the value based on this. So RW minus, it's 6. R minus minus, it's 4. Minus RW minus, it's 6. So this is the value. Now you deduct this from 666. So 666 minus 646. It's equal what? 0, 2, 0. Why I'm deducting from 666? Because this is file permission. So 0, 2, 0. So my UMASK will be 0, 2, 0. So now if I go to Linux, good, I'm going to, my current UMASK is 002, 022. So I'm going to make a new file called file 99, and I will going to look at the permission, and you look at the file 99, it's getting what? RW minus R minus minus R minus minus by default. Now I'll change my UMASK to this value that I calculated here, which is 020. So UMASK equals 020. So it has been changed. So now if I create a new file, and I'm calling that file 88. Oh, sorry, touch file 88. Now I look at it. Look at the file 88. What permission did it get? It got RW minus R minus minus RW. This is what I was asking for here. Look, the previous files didn't change, and they will not change. The UMASK only affect the new stuff. So if I create another file now, 889, the new file that I create will have the same permission. And any new files I create will have the same permission until I change the UMASK again. Good. So this is how we set up the UMASK. This is how we calculate the UMASK. There is one example for you guys to figure it out by yourself on this document. Good. I hope it's clear enough. Thank you very much.